All right, so for this first one, the first thing it asked us to do was to sketch the slope field. This was the first one this was page 3, right? Yeah, does that look right to everybody? Okay, cool. So it said just sketch the slope field for the differential equation at the 6 points that are given to us. So the first thing that we would note is that if y was equal to 0, what's the slope? Or what is dy dx equal? Equals 0, right? Unless x is 1. But they didn't even give us a point to do at x equals 1, right? So we don't have to worry about that. So these two should be 0. Yeah. And then for the other 4, I mean, it's such a few, I mean, it's hardly any points, right? So just plug in each of those points. The point 0, 1, what do you get if you plug in 0, 1? -1, so it should look about like, that's atrociously curved. About like that, good enough. Yeah. Doesn't have to be perfect, just pretty good. The point 0, 2, what do you get? Negative what? -4. So it should be negative, but pretty steep. That's good enough, right? What about the point 2, 1? What do you get? 1, yeah. And at the point 2, 2, you got to get 4. And so just fairly steep. Pretty easy. Anybody have a question on the slope field? Zoom people have a question on the slope field? Okay. And as is generally the case when they ask you to sketch the slope field, if there are some slopes that are 0, they will give you 1 point for all the ones that are 0. And then they will give you 1 point for all of the rest of them, usually. Okay. So that was worth 2 points for part A. Everybody good there? Zoom good?
Do we need to do the slope field from like 0 to 1 and from 1 to 2, or just at the points?
What?
Like, do we need to like kind of fill in the lines as what we think?
Do you need to sketch the solution curve? No.
Okay, thank you.
Yeah. Just the little tick marks there, just little short little line. That's all you need. Any other questions? No? Great. Okay. Next, we're saying y equals f of x is the particular solution to the differential equation given this initial condition. We want to write the equation of the line tangent to f of x. Okay. So y equals f of x is the solution to this differential equation. We want the tangent line to y equals f of x to the solution of this, which means we need the tangent line, we need a slope, and we need a point. Right? And we're going to get the point, well, from right there, they gave it to us, right? The point we're going to use is 2, 3. How are we going to get the slope at that point, 2, 3? Plug it into our derivative, right? Plug it into our differential equation because that gives us the slope. So if x is 2 and y is 3, what do we get? Should get, looks like 9. Yeah. You guys in the Zoom really don't hear that weird sound the computer keeps making?
I just heard that one.
Yeah. That's really fun. All right, so the equation of our line is y minus 3 equals 9 times x minus 2. And they gave you 1 point if you got the equation. So 1 point for the equation. And then they asked you to approximate f of 2.1. So you're just going to plug in 2.1 for x. So you'll have y minus 3 equals 9 times 0.1. And then that'd be 0.9 plus 3 should be 3.9. And that was also worth 1 point. So 4 points from parts A and B, which leaves how many points for part C? 5 points for part C, because they're all worth 9 points. So part C is the part where it asks you to find f of x, find that particular solution given that initial condition. So we'll need some room on the next page to do that. We've got dy dx equals y squared over x minus 1. And so like I said, most of these differential equations, they're going to give you a separable differential equation. And the first step will be to separate the variables, right? We're going to separate the variables. So we're going to bring the y squared over here to the left, dy over y squared. We're going to bring the dx to the right, dx over x minus 1. Everybody good there? That already is 1 point. If you just do that, you get 1 point. Then you need to integrate both sides. Okay. Y squared in the denominator, that's a y to the negative 2. So how do we integrate y to the negative 2? What? The power rule. It's just y to the negative 2, right? You go up to y to the negative 1, divide by negative 1. We get negative 1 over y. And then to take the antiderivative of dx over x minus 1, you can just do like a really easy u substitution, like u equal x minus 1. And if u equals x minus 1, then du is just dx. So really this just becomes the integral of du over u, which is natural log absolute value of u. You don't have all of this over here. You don't have to write that out if you don't need to do that for it. But just be careful. If that's like a 2x minus 1, then u is 2x minus 1 and du is 2 dx, then you have to actually put in the 2 and the 1/2 and do it. This should be, then it would be 1/2 the natural log of that. Does that make sense, everybody? And don't forget your plus c. Good? All right, according to the scoring guidelines here, they gave you 2 points for correctly getting the antiderivative. So to getting these, that was 2 points. If you forgot the plus c, you can't get more than 3 points on it. If you put the plus c, they didn't just give you a point for it this time. Sometimes they just give you a point for writing plus c. In this particular one, they didn't. But they did give you a point if you made an attempt to solve for c. So if you plugged in your initial condition, which was 2, 3, is that right? 2, 3. So if you went and did this, they gave you a 4th point. So there you go, point number 4. And your constant ends up being negative 1/3, right? Because the natural log of 1 is 0. And so we then have negative 1 over y equals natural log absolute value x minus 1 minus 1/3. And if you want to, you can get a common denominator here, combine these together before you take the reciprocal. Or they would be okay if you just do this. That would be fine also. Okay. And then you can divide by the negative, and you end up with y equals negative 1 over that same thing. That's a perfectly acceptable answer. Let's see. That's not quite how they wrote it on their scoring guide. They distributed this negative through the denominator, so there was 1/3 minus natural log absolute value x minus 1. That's also fine. This would be fine. Had you gone through and made this 3 natural log absolute value x minus 1 over 3, and then took the reciprocal of it that way with a 3 over natural log x minus 1 minus 1, that'd be fine too. Any of those are fine. Good? Feel okay about that? Feel like if we had a quiz on these like next week, we could do it? We're going to practice more of them between now and then, but we feel like they're doable. Yeah. Okay. Cool. All right. Zoom, are you guys good?
Yeah.
Yes.
Wonderful. And nobody had any questions on any of that last part? No, everyone's good. Okay, cool. Then let's look at this one. So this was the next one. 2x minus y was our differential equation. This one's a little bit different than, and maybe a little bit more difficult than the last one in general, but it's got some good stuff in it. So what did your slope field look like? You just had 6 points to plug in again, which is convenient. How about at 0, 1? What did you get? Negative 1. How about at 0, 2? Negative 2. Oh, that's too steep. How about at 0, -1? +1. How about at 1, 1? Just a 1. How about at 1, 2? 0. And how about at 1, -1? 3. Sound good to everybody? Yeah? All right. I was pulling up the guidelines on this one, and then I thought I had it up, but I didn't. I'm pretty sure that was worth 2 points. I'll tell you in a second once this loads. Second part of it, finding the second derivative. So how do we find the second derivative if we already have the first derivative? What do we need to do? Take the derivative of it. And we need to do it with respect to x. So the second derivative, what's the derivative of 2x? 2. And the derivative of minus y with respect to x. Minus 1 dy dx, right? And how are we going to rewrite that then? 2 minus 2x minus y, or 2 minus 2x plus y if we want to. Either of those are fine. Okay, so it looks like they gave you, okay, so it was 2 points for your slope field. Literally 1 point for this one, and 1 for all of the rest. And then the second derivative here was worth 1 point. And then they asked you to determine the concavity of all of the solution curves in quadrant 2. Okay, so if we have nothing showing in quadrant 2, right? But if we think about the concavity in the second quadrant, what do we know about points in the second quadrant? X is, like this, negative, and then y is positive. So if we think about plugging in a negative x value, well, that's going to make this a negative, right? So we've got a positive number, and then a negative is going to be another positive. So we have positive plus positive plus, and then y values in the second quadrant, like we said, are always positive. We have a positive plus a positive plus positive, which is positive. So what does that tell you about the concavity of any solution curve in the second quadrant? Should be concave up. And we would want to say, always positive second derivative based on negative x values and positive y values, or something like that. And that concave up it's always positive. The second derivative is always positive is worth another point. Yeah, 1 point. Good? Yeah.
Like, you have to say, like,
if you probably don't have to specifically say because x is always negative and y is always positive. I mean, you could just say that in the second quadrant, the second derivative is always positive. Their specific explanation, their explanation did use it. They said x is less than 0, y is greater than 0. So 2 minus 2x plus y is greater than 0. But I don't think you have to state that. You just say concave up and it's always positive, and have a little bit of work there to show something to show that you indicated why it's always positive. Other questions on that? Anybody in the Zoom questions? Anybody here questions? All right. Part C, we're going to have to go to a new page. Part C says f of x is the solution, the particular solution at the initial condition that f of 2 is 3. And we want to know, does f have a minimum, a maximum, or neither at x equals 2? All right. So we're talking about the point 2, 3. If something has a minimum or a maximum, what does that mean about its derivative? It needs to either be 0 or it could possibly be undefined, right? So we want to know, does dy dx evaluated at 2, 3 equals 0? Or is it undefined? Well, it's definitely not undefined, right? We know that for sure. Our derivative, now I don't remember what it was. Was it 2x minus y? Is that the derivative, 2x minus y? The 2x minus y evaluated at the point 2, 3 equals 1. Can you have a maximum or a minimum when the derivative equals 1? No, right? We'd say no critical point. There's a no critical value. So no max or min, or you'd say derivative doesn't equal 0, isn't undefined, so no max or min, or something like that. And you would say neither. And just a basic explanation there that, you know, the derivative doesn't equal 0 there, and it's not undefined there, with a little work to show is a good enough explanation. And they gave 2 points for that. 1 point for making an attempt to find the value of 2x minus y at that point, and then 1 point for neither with some sort of justification. It makes sense. They specifically wrote, you know, they didn't even talk about it being undefined. They just said 2 times 2 minus 3 equals 1 does not equal 0. Yeah, good enough. Good? Everybody good there with that one? Zoom, any questions on that? All right. Now, part D. Part D for this one is a little bit more difficult. We want y equals mx plus b to be a solution to this differential equation. So we're looking for the constants m and b that make that true. Okay. So what does that tell us? This is the solution to the differential equation. So this thing's derivative needs to be what?
Two x minus y.
Needs to be 2x minus y, exactly, right? The derivative of the solution to the differential equation should be the derivative. Well, what is the derivative of y equals mx plus b? Just by taking its derivative.
M.
To be m, right? M is a constant, b is a constant, mx, the derivative of that is m. The derivative of a constant, b, is just 0. So we can say that not only does dy dx equal 2x minus y, but dy dx also needs to equal m, right? So we can set m equal to 2x minus y. And I think, let's see, yeah, they gave you 1 point, 1 point for showing that dy dx was equal to m. So 1 point for that. And then they gave you a second point for doing this. And then you have to do a bunch of work to get to the third point. So how are we going to figure out the constants for m and b then, given this? We know this is true. Is there anything else we can do with this? All right, we know that y equals mx plus b. So that can at least, we can, if we put that in here, that can at least give us both m and b in here. Okay. And then what can we do? Anybody know how to solve that to figure out what m and b are? A little bit tricky. Let's try this. So let's take and get everything on one side. So we're going to have 2x minus mx minus b minus m equals 0. Yeah. Yeah, so just for people in the Zoom, somebody was asking how we went from this step to this step. Right, that's what you're asking, basically. Yeah. So we had our original, we knew that originally we know that y equals mx plus b just based on what it told us back there in the problem. So all we did was we just replaced the y with mx plus b to get rid of, because right here we've got m, we got x, we got y. What we really need is we need a b in there because we're trying to solve for b. So we found something that had b in it in terms, or y in terms of something with b that only included other variables that we already had in there. So then we just put them together. Does that make sense? Yeah. Cool. Zoom, you guys good so far?
Yeah.
All right, now we have to use a little trick here. How many x's are on the left side of this equation? What? How many x's are over here? 3? Aren't there 2 minus m x's? Can't I factor an x out of that? 2 minus m times x. So there are 2 minus m x's. How many x's are on the right-hand side of this equal sign? I need these two things to be equivalent. So what does that tell you about 2 minus m? It needs to equal 0. The number of x's on the left has to equal the number of x's on the right. There are no x's on the right, and there are 2 minus m x's on the left. I have to have the same number of x's. So what does that tell you about m? M must be 2. How many, or what is the constant on the left-hand side? Isn't that the constant? That's the value of the number that's not associated with x that's sitting over there. So negative b minus m. And what's the constant on the right? 0. Right? I need both m to be 2 and I need negative b minus m to equal 0. So negative b minus 2 needs to equal 0, which tells me that b needs to be negative 2. So if we have m equals 2 and b equals negative 2, that ought to be a solution to this differential equation. So the equation would be, I don't think it didn't ask for the equation, it just asked for the answer, which the final answer of both those numbers is worth 1 more point. The equation itself would be y equals 2x minus 2. Now, when we think about this being our equation, the derivative of this is supposed to be 2x minus y, though. Does that look like the derivative of it is 2x minus y? It certainly doesn't look like it, but we can be certain and check our work if we want. Our equation is y equals 2x minus 2. And what is the derivative? dy dx. The derivative of this is 2, right? Well, we also said the derivative dy dx is 2x minus y. Well, we know what y is now, right? So if we wanted to, we could check that 2x minus y. Right? The y that we had, that we got. And what's 2x minus 2x minus the negative 2? 2. So they are equivalent to each other. They just, it's just a little bit of a weird looking form of it, but 2x minus y is, in this case, equal to 2. Does everybody see that? That one's a tricky one. The first 3 parts of that, I think, were pretty easy. Last part of it probably tripped some people up. Yeah. That's the way it was back in, what year was this? 2015, when this question was on the AP test. Right? People did really well on parts A, B, and C and struggle with parts C. And, once every 5-6 years, they throw something a little tricky like that on there with the differential equations. For the last part, it's not just the solving the differential equation. So just be aware of that. It's been about 5-6 years. So maybe they'll throw something like that on there. Who knows? I mean, they got 3 different tests they're making, so I bet somewhere in those 3 tests there will. Any questions?
Could you explain why negative b minus m had to equal 0 again?
Yes, and then I'll get your question right. Negative b minus m has to equal 0 because everything on the left-hand side of this equal sign has to match up with everything on the right-hand side of this equal sign, right? And I know for the same reason that I knew that 2 minus m had to be 0 because there were 0 x's on the right, so I needed to have 0 x's on the left. Same thing here. The rest of the numbers on the right are 0, And the rest of the numbers on the left are negative b minus m. So the numbers on the left have to match up with the numbers on the right. Does that make sense?
Yeah, thank you.
Yep. Ryan, what's your question? C? No, C was neither because the derivative didn't equal 0 at that point that they gave us. The derivative was 1. Everybody good now there? Yeah. Any other questions on that? Everyone's good? All right. Next one. Let's see here. See if I can pull up the answers to this so I can tell you how much things are worth. I told you how much everything was worth on the last one, right? Yeah, okay. All right, sketch the solution curve through the point 0, 1. Well, what's that going to look like? 0, 1 is this point right here. Let's pick a different color. Something like that. Something not like that. Just make sure that you extend it all the way to the edges of the slope field, and that should be good enough. They gave you 1 point for that. If yours extended further down, that's fine. If yours extended a little further up, that's fine. It just needs to be pretty close. It doesn't have to be perfect. So just 1 point for that one. Good or no? Easy enough? All right, part B, write an equation for the line tangent to the solution curve. Now you've seen this, I think, in 3 straight problems. This is very, 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 very common on the differential equation FRQs. Write the equation of the tangent line to the solution in part A at 0, 1. So we need a slope and we need a point. Well, we're given the point, right? The point is 0, 1. And the slope then should be no, I didn't actually do it. What do we get? We get 3 minus 1, right? Which is 2, yeah, times the cosine of 0. So 1 times 2, our slope is 2. Everybody good with that? So our equation, this is just they gave us a y-intercept, so if we want to, we can just write y equals 2x plus 1. Or if you want to write y minus 1 equals 2 times x minus 0 in point slope form, that's fine too. But since it's a y-intercept, you can just go straight there. Good? Okay. 1 point for that. 1 point for that. And then approximate f of 0.2. 2 times 0.2 plus 1. Looks like that's 1.4. And that's another point. So 3 points for parts A and B, leaving you with 6 points for part C. A lot of points for part C. Yeah. So if we're going to solve that differential equation, 3 minus y times cosine x, what do we need to do first? Step 1 is separate the variables. dy over 3 minus y equals cosine x dx. One point, just for separate. All right, next is integrating both sides. All right, the right-hand side should be easy. The integral of cosine x is sine x. Don't forget your plus of c on the right-hand side. And then on the left-hand side, dy over 3 minus y, that one requires you to do a u substitution. So u equals 3 minus y. du is negative dy or negative 1 dy. So you'd have to put in a negative and a negative, right? And that would become negative integral du over u. So that should become negative natural log absolute value of u, or negative natural log absolute value of 3 minus 1. Everybody good there? Zoom, are you good with that?
Yep.
Wonderful. Okay. For the antiderivative, they gave you 2 points. So they gave you 1 point for this antiderivative, 1 point for this antiderivative, plus they gave you 1 point for literally writing plus C. So that was nice of them. I don't know why my laptop keeps making these marks all over it, but it's driving me crazy. All right. Still part C. We got to finish solving this and find the constant. So what was our initial condition? Was it 0, 1? Yeah, 0, 1. So if y is 1, this is negative natural log absolute value of 2 equals 0 plus our constant. So our constant is negative ln 2. Fifth point, finding the constant properly. And then your last point is, the most difficult point is solving for y. So we put in our minus ln 2 as our constant. First thing that we will do is get rid of this negative sign. How do we get rid of the negative sign? Yeah. Divide or multiply by a negative 1. So what is that going to do? That's going to flip the signs of both of these. So we could rewrite this as natural log of 2 minus sine x if you wanted. Everybody good with that? How do we get rid of the natural log? E to the power of both sides. Yeah, we call it exponentiating, right? Exponentiate both sides. So e to the natural log of anything is just that thing. So we have absolute value 3 minus y. And then here we have e to the ln 2 minus sine x. How could we rewrite that? What can we do with the e to the ln 2 part of it? Yeah, bring the 2 out in front. So we have 2e to the negative sine x. And then we need to clear off the absolute value. And when I clear off the absolute value, it either becomes a plus or a minus on the right-hand side. How do we determine which it is, the positive or the negative? True, but I could still put a negative out in front. I might still need a negative out in front. So there's a specific way we can determine which one we want. So we got to go back to our initial condition. So if we go back to our initial condition, that's the point 0, 1, right? 0 for x makes this e to the 0, right? Which is 1. And then 2 times 1 would be 2. And we'd want 3 minus 1, which is 2, to equal 2. So if I put a negative in front of it, I'd have 3 minus 1 equals negative 2. That's not true. 3 minus 1 equals 2, right? So we need it to be the positive version. Sometimes, though, they will, if my initial condition had been, I don't know, I guess, if y equaled 5, let's say, then we would need to put the negative 1 there. Does that make sense to everybody? Yeah. All right, then I'm going to add my y to the right-hand side and then subtract the 2e to the negative sine x. So I'm just going to get y equals 3 minus 2e to the negative sine x. So a lot of work there to get to the 6th point. Points 1, 2, 3, 4, and 5 probably were hopefully pretty easy there on part C. But getting to the last point might be a little more difficult. And they make a note that you can't get more than 3 out of 6 if you forget your constant of integration. And you cannot get anything more than 0 out of 6 on it if you do not separate the variables. Right. So even if you leave the 3 minus y over here and still get the integral of cosine x right as sine x, but try to write the integrals over here of 3 minus y is 3y minus y squared over 2, and get one of them wrong and put a plus c, you still wouldn't get the point for doing the cosine integral correctly or putting the plus c because you didn't separate the variables. So you must separate the variables. Good? Any questions? $1.4. No. I mean, we were just evaluating, we got this equation. So somebody was asking about part B again. We got the equation and they just asked us to approximate it at 0.2. So we just plug in 0.2 for x. Everybody good there? Any questions there? Anybody else? Everybody's good? All right. This one, you can tell there's going to be a lot of points for part B because there's only 2 parts to this one, right? This is a little, the further back you go in time, I think this one is 2013. That last one is 2014. The easier they seem to get, I feel like, in general. So they're making the test more difficult every year. Lucky you guys. At least you're not next year's class. So we want to look at this differential equation. We've got a particular solution, which is f of x that goes to the point 1, 0. And then first thing it says is write the equation of the tangent line. That should be really easy. We've done that a lot of times. So how do we do that? Slope and point. Point is 1, 0. Slope just comes from evaluating dy dx at the point 1, 0. So if x is 1 and y is 0, what does that give us? That gives us a 1 times a -3. Gives us a slope of -3. Everybody good with that? So we should have y minus 0 equals m times x minus 1. And then they again want us to approximate a value of the function using that. So we're going to approximate 1.2. Which looks like it should give us -0.6. And let's see here. How many points did they give you for that? They gave you 3 points for that, amazingly enough. They gave you 1 point for a slope of, that's not a good color to use. There we go. 1 point for a slope of -3, 1 point for the equation, 1 point for the approximation. Good or no? Everyone good at home?
Yeah.
Wonderful. All right. Then we're going to find a particular solution. So once again, what's the first step? Separate the variables. dy over e to the y equals 3x squared minus 6x dx. Once again, 1 point for separating them. Then you got to integrate them. Okay. So on the right-hand side, that should be easy. That should become what? X cubed minus 3x squared plus your constant. What about on the left-hand side? How are we going to integrate dy over e to the y? No, it is not. That it only works if it is just a single variable in the denominator. You would have to do a u substitution to make that work. You cannot do, and that is one of the most common mistakes that people make. That they see something in the denominator, right? And then they just say, oh, the integral of that is natural log of that thing. That is not true. Not true. And if it's a function down there, you have to do a u substitution with it. If it's, if it's just x, sure, that's fine. If it's anything other than just x or just u, you have to do the u substitution. And if I tried to do a u substitution, u would equal e to the y, and du would be also e to the y. I don't have another e to the y, though, to get rid of, so that's not going to work. We're going to have to find another way to integrate that. Anybody got a good way to integrate that? I would love to rewrite it as e to the negative y dy. Everybody agree with that? That seems good. We can move that e to the y from the bottom to the top by changing the sign of the exponent. And then now we can do a u substitution. What are we going to u sub? Yeah, if u is negative y, then du is negative dy. So we'll put in a negative and a negative. This becomes negative integral e to the u, du, which is negative e to the negative y. So we get negative e to the negative y equals x cubed minus 3x squared plus c. And let's see, same thing as the last one. 1 point for this integral, 1 point for this integral, 1 point for plus c. 1 point for finding c. So plugging in x equals 1, y equals 0. So negative e to the 0 is negative 1, right? Negative of e to the 0, right? Negative 1. And if we plug in 0 over here, that's just c on the right-hand side, right? I'm putting in 1. Sorry, my fault. Putting in 1. 1 minus 3 plus c. So what's our constant? Should be 1, yeah? Okay. So now we've got negative e to the negative y equals x cubed minus 3x squared plus 1. And we want to solve for y. So first thing we'll do is multiply by a negative 1. Everybody go with that? You can distribute it through if you want, doesn't matter. What about next? What should we do? Take the natural log of both sides. So that's going to give me negative y equals natural log of negative. I'll just distribute it through. Negative x cubed plus 3x squared minus 1. And then we just need to multiply by another negative 1. And that is the 6th point. Forgot to mark. Getting the constant of 1 was the 5th point. But then getting that as your final answer is 6. Everybody here good? Zoom, are you guys good with that?
Yep.
Wonderful. Everybody's feeling pretty good? When did we? Right here. After we integrated. As soon as you integrate, solve for c. Once you've integrated both sides and put your plus c, put in your initial condition and solve for c. So we plugged in 1 for x, which gave us 1 minus 3 plus c. We plugged in 0 for y, which gave us negative 1 on the left. Gave us a constant of 1. Everybody good? Y'all good here? Yeah? Yeah. Zoom, you're all good?
Yeah.
All right. One of you is good. One of the other 20 people in the Zoom besides me.
I am also good.
2 out of 20. 1/10 of the Zoom is good. That's great. Amazing. All right. So next up is you had a homework assignment. Actually, you've had a couple of homework assignments. One I posted yesterday, one from a couple of days ago of the solids of revolution, like for tomorrow's quiz. Anybody have any questions on those? I'll also go over some tomorrow before class, or not before class, but before the quiz tomorrow. Questions on any of those homework assignments? That's not a question on the homework assignment, but sure. Anybody? Questions on the homework assignments? Questions on the homework assignments? Nobody? I'm trying to patiently wait, but I'm not a very patient person. How many of you people here in person have done those homework assignments? 2.5? That's very non-committal back there, Serena. Okay. That's not good. Oh, something in the chat. Oh, 2 people said things in the chat. That's exciting. Okay. Number 7 on the first assignment. Okay. And then what was it? Myra, do you want number 6 off the first paper or the second paper?
The first one.
First one. Both those are off the first one. Okay. Let me take a look here. Simple solids of revolution, number 6 and number 7. Exciting. So, number 6 says we've got y equals x, and we've got y equals negative x squared plus 4x minus 2. And we are taking the region between those and revolving it around the x-axis. So first thing that we should do is we should sketch the region. Y equals x is pretty straightforward, right? Y equals x. And then y equals negative x squared plus 4x minus 2. Well, that's a downward facing parabola. True. That has a y-intercept of negative 2. Is that the right equation? Negative x squared plus 4x minus 2. Y equals x. Okay. All right. I am reading that right? Negative x squared plus 4x minus 2. All right. Where do those cross then? Let's see. Negative x squared plus 4x minus 2 equals x. We'll figure out where they intersect. That'll help us out. So we'll end up with x squared minus 3x. We bring these over, plus 2. And that would be x minus 2 and x minus 1. So those should intersect at x equals 1 and x equals 2. Oh, right. That would make sense. That's just my intersect. Okay. What are the x-intercepts of this? They're over there. What is the vertex of that parabola? Anybody got the vertex of that parabola? What is that? At 2, right? No. Okay, yeah. The vertex of that parabola is at the point 2, 2. Okay, there we go. So it looks something like this. That looks horrible. There we go. So the region that we're looking at is this one. Everybody good with the sketch of the graphs and the region? Yep. Oh, yeah. Sorry. Yes. Everybody good with the sketch of the graph and the regions? Or the region? All right, we're going to take that and revolve it around the x-axis. Is that region fully pushed up against the x-axis? No. So if it's not fully pushed up against the x-axis, what do we need to do? We need to do washers. So this should be an integral with pi out in front from the intersection points, which we found to be 2 and 1. So from 1 to 2 of the outer radius squared. What's the outer radius? The distance from the x-axis to the upper function. So that'd be negative x squared plus 4x minus 2 minus the inner radius, which should be just x. So x squared dx. Good or no? Good or no?
Good.
Okay. All right, so then we'll distribute out the negative x squared plus 4x minus 2, which is going to be a little bit of a pain. What is that? X to the 4th, and then what we're going to have? We're going to have a minus 8x cubed. And then we're going to have a plus 20x squared. And then a minus 16x, and then a plus 4. Is that distributed? Did I distribute that right in my head? Yeah. Okay. Hopefully so. All right. And then we'll combine our like terms. We have 20x squared and x squared, which is going to give us a 19x squared. And we're going to have some really unpleasant arithmetic to finish this off with. Yeah. Fun. So we have pi integral 1 to 2 x to the 4th minus 8x cubed plus 19x squared minus 16x plus 4. Everybody okay with that? Oops, this was number 6, right? Maya, are you good with that so far? Myra, are you good with that?
Yeah.
Okay. And then now we'll just integrate. So we got pi x to the 5th over 5 minus 2x to the 4th plus 19 thirds x cubed minus 8x squared plus 4x, all from 1 to 2. And from there, it's just arithmetic. The arithmetic's not so pleasant, but that's fine. 32 fifths minus 32. What's 8 times 19? That must be 152. Yeah. Plus 152 over 3 minus 32 plus 8, and then minus a fifth minus 2 plus 19 thirds minus 8 plus 4. Do you want me to finish the arithmetic, or is that good enough? Yeah.
You have to like fire it all the way down to the 18.
Yeah, you should not leave it like that. Yeah. That's not a good way to leave it. I guess we could do it. All right. Pi times, what is that? 31 fifths minus 64 plus 8 is a minus 56 minus 54. What is that? Minus 46 minus 50, I guess. And then 152 thirds minus 19 thirds. What is that? 133 thirds. And then get your common denominator and get an answer. Yeah. We can, I guess we'll finish. All right, we'll finish it. What is that? 93 minus 750 plus, what is that? 665. You multiply that by 5, is that right? Yeah. Over 15.
Isn't that a 32?
This 31.
Yeah, is that a 32?
No, it's a 31. 32 fifths minus the 1 fifth over here. Yeah, you see what I'm saying? 32 fifths and then minus the 1 fifth on the other side over here.
Yeah.
Okay. What does that come out to be there? 8 pi over 15? Is that right? Oh, the answer is not too bad looking. This is some fun arithmetic, huh? Exciting. Good times. All right. Maya, are you good with that or no?
Yeah, thank you.
Sure. All right, let's look at number 7. Number 7 said, we've got 2 plus sine x. There's 2 plus sine x. And we got 1 minus cosine x. So let's see, 1 minus cosine x is going to look like, let's see, it's going to start, should be up 1, but it should be flipped. So it should be going down. It should be something like that. I don't know. Something like that. That's not great. It should be more like that or something to that effect. And we're going to revolve it around from x equals negative pi over 2 to x equals pi. 1 minus cosine x. That's not looking right. 1 minus cosine x should be on. Oh yeah, it should be going up first. So it should be something like that. Some region sort of like that. Yeah. I think I had a picture on the answer key. Yeah. It should look something like that. And we're talking about from negative pi over 2 to pi. And so from negative pi over 2 to pi. We're going to revolve that around the x-axis. And so is our region fully pushed up against the x-axis? Now it touches the x-axis, but it's not fully pushed up against it on that entire section, right? So it's going to be washers. So pi times the integral from negative pi over 2 to pi of our outer radius. So from the x-axis to the upper function, which would be 2 plus sine x, right? 2 plus sine x squared, and then minus the lower function, which was 1 minus cosine x squared. Good or no? Everybody good with the setup there? Okay. All right. Zoom, are you good with the setup? Who asked that question? Angelina, you good with that one, the setup?
Yeah.
Okay. All right, so then we will distribute all this out. That should be 4 plus 4 sine x plus sine squared x. And then we should end up with a minus. And then we've got 1 minus 2 cosine x plus cosine squared x. And we'll combine our like terms. We got a 4 minus the 1 should be a 3. We've got a 4 sine x. We've got a plus sine squared x. How are we going to deal with plus sine squared x? What? With what? I didn't hear what you said. With what of the power reducing identity? That you said? Yeah. That works. So sine squared x is 1/2 of what? 1 minus cosine 2x. And then we already did the minus 1. So we're going to have a plus 2 cosine x, and we're going to have a minus cosine squared x. So that should be minus 1/2 of 1 plus cosine 2x. Good? Okay. Now, we're almost ready to actually integrate. One more simplification here. We got the plus 1/2 here, and we got a minus 1/2 there, so we can get rid of the plus 1/2 and the minus 1/2. So we're just going to have 3 plus 4 sine x minus 1/2 cosine 2x plus 2 cosine x, and then minus 1/2 cosine 2x again. And I guess we could combine the minus 1/2 cosine 2x and the other 1/2 cosine 2x to just become a minus cosine 2x. So I guess I was wrong. There's still one more simplification. 3 minus the cosine 2x, we have a plus 4 sine x and a plus 2 cosine. And now we can integrate. Yeah? 3x. And we talked the other day about how to quickly integrate something like cosine 2x. It's a u substitution, but we should be able to do it in our head, I hope. What does that become? Minus 1/2 sine 2x. Good. Integral of plus 4 sine x is minus 4 cosine x. Integral of plus 2 cosine x is plus 2 sine x. And we go from negative pi over 2 to pi. Everybody good there? 3 pi minus 1/2 of the sine of 2 pi. What's the sine of 2 pi? 0. So 3 pi minus 0. And then minus 4 cosine of pi. What's the cosine of pi? Cosine of pi is negative 1. So negative 4 times negative 1 is a plus 4. Then we got plus 2 times the sine of pi, which is plus 0. And then we got minus. We got a negative 3 pi over 2. And then we've got, let's see, the sine of negative pi is 0. So minus 0. The cosine of negative pi over 2 is 0. So that's another 0. And then the sine of negative pi over 2 is negative 1. So this becomes a minus 2 there at the end. And now it should be easy enough to simplify. We got 3 pi plus another 3 pi over 2. So that should be 9 pi over 2. And we got a 4 minus negative 2. It should be a 6. Good or no? Angelina, good with that or no?
Yeah.
Wonderful. Any other questions? We have time for maybe one more if there's another one. Nobody? Zoom people, any other questions? Okay, I guess we only got like 6 or 7 minutes left, so we'll probably just stop there. Tomorrow, we'll have a quiz on solids of revolution. It will not take the whole period. We will spend the first part going over any questions you might have from the homework, and then we'll do the quiz the second half. And don't plan on any extra stuff tomorrow during class. Other than that, and I think that'll probably take the whole time. And then we will probably on Monday, we will definitely on Monday, we will talk about shells. And then we will also start looking at some of the area FRQs, and we will also try to look at the anti-differentiation multiple choice and potentially the definite integrals multiple choice, just depending on how things are going. I'm going to assign you guys over the weekend, though, a bunch of area and volume FRQs to work on so that you can get started on those. Because every single year there is an area or volume FRQ. I mean, there's been like 1 year in the last 20 where there wasn't. So pretty certain you're going to see. Sound good, everybody? All right.